Hi, it's Gadget UK here again, back with the junk Commodore 64 motherboards. So you saw this in the previous video there, one of the three boards we fixed. This one I think we can probably fix. The third one is just going to be parts. I might cover the third board in this video as well, perhaps. So yeah, in the previous part, you'll remember that we removed an 06 from there. So we need to get that back on, but this needs two sockets for CIAs. It needs a socket for the CPU and a socket for the PLA. How do you know that's the PLA? As we mentioned in the previous video, you've got two caps here. Those are the filter caps that go to the top 4 pins there, which means this is the SID. Unlike some of the previous boards you've seen on my channel, where those are the opposite way around. SID is up here on the, I think it's a later board, and the PLA's down here. So yeah, and obviously we need to get the VIC in there, but other than that, it's got a crazy fuse there to swap out. Power switch. I haven't got a spare power switch now. I can order one, but I think for the purposes of just trying to get the submarine, I'll solder the contacts across there just to put it in the on position. It's got a cap missing there as well, so we'll backfill that. And then it's just a case of inspecting around, see if we can find any other missing components or damage. It's strange, isn't it, how someone's lifted that out? I don't know why they would do that. Because looking around the sea, very few components have got a cap there. Look, someone's started to remove that cap and then given up. So I don't know, maybe they removed with hot air and one or two things just fell out of the holes. That's a possibility. Let's just move those out of the way. You want a really beefy tip on your soldering iron when you're doing things like this, because it won't pass the heat, but it will when you add a bit of solder. And I could just crank up the temperature there. I'm going to need to do that, I think, because that ain't melting. There we go, got it off. So let's just add some flux there, and let's just mop up that solder. Looks like someone's touched that with the iron there. That could be a cobweb. And there's obviously some solder to remove, I'll show you in a sec, just near the cartridge slot as well, so we'll deal with that. So this must have been one of the revisions that had that big shield, you know, soldered on all the way around the edge of the board. I know a lot of the US ones did, but even when I was back in the trade, I never saw one where that was like soldered on all the way around, I don't think. But yeah, you can see that's a bit better. And we'll get rid of these ones at the front as well. Yeah, so like I say, I never came across one. I mean, technically I still haven't. This hasn't got it on, has it? Someone's got there before me and removed it. Probably the quickest way of getting rid of this actually is heating it up till it starts to melt and then use the desolder pump and then use the braid. You can see, look, large amounts of it removed that way. So we've got a screw there to remove. I will straighten up all of these caps and stuff as well, just so that we can make sure nothing's shorting, and inspect. You know, there's some corrosion there on the end of that. But let's just get that screw out. That looks pretty corroded to me. Yeah, that's not going round. It's going to have to come off that. But yeah, try and grip. It may chop off. I don't think so though. You've got to use mole grips. Oh, that is well and truly stuck on. Yeah, the problem is here, you can see this is broken here. How that broke, I don't know, because it's like solid aluminium. Someone must have wrenched that off actually. Well, I'm going to deal with that screw later. I just can't get it off, and I'm going to end up mangling this area over and over if I'm not careful. The easy thing to do maybe to Dremel to get a nice flat groove into it, so I can get a flat blade onto it, but I need to grip the thing from the underside because that's where it's corroded on. The other thing I could do is just drill right into the head and then use the cutters to cut the last bit off, and then it should come off. So we can deal with that, but I think I'll get rid of that next actually. Let's just see. I'll crank the temperature of the iron up. I'm going to go right to 480 just temporarily. There's also a little bit there, a metal bit, sharp bit, could cut yourself on it, so I'll heat that, get rid of that. And then a bit down that way and a bit on the bottom, but we're almost there in terms of getting those bits of solder off. And of course, you know, you could argue, waiting to see if you can fix it. Well, we know we can fix it, because where there's a will, there's a way. You can fix anything if you put your mind to it. It's just all about spending the time on it and being persistent. What you've got to watch for is you don't just attach your braid, which is what I'm doing. It is removing the solder, but just like a bit at a time. Probably better off with a small amount like that, small surface area if you've got a small tip, because you will just join it, as you can see. We are getting there though. It doesn't look like it, but trust me, we are. Yeah, so hopefully you can see the technique there, a case of pulling upwards. Small surface area, pull upwards. And for the eagle eyes, we've got 2 blobs of solder there to remove as well. It's like, I don't know what's happened to this. Has it got all these bits of solder everywhere on it? So next we'll get some flux onto the braid. Just extend it a little bit. And we'll have a go at trying to absorb whatever that is. I think that's solder. Yeah, going to do a couple of passes here, I think. Not sure if you can see very clearly, but those are bits of wire. That's what that is. It's had some wire wrapped around it. So we'll just see if we can, I don't know, heat and pull it off. You can see I'm moving it, look. Just see if we can somehow, I don't know, shift it around. Yes, hopefully you can just about see these little bits of wire. I've got them all around off the circumference of that pin there, so there's a load of bits of wire there to get rid of now. Right, those are off, so let's get a little bit more flux and solder, and I'll just give them another going over. Now the wire's not there. And the pin's next to them as well, just in case someone smeared solder just nearby. But I just wanted to get those off because it just looked an eyesore and I wasn't sure what was going on really. But you can see those wires have gone. The next thing we'll do is get that back into its hole. It's going to be that hole there because that's big enough for a leg. The others are just like tiny little wires, and I can compare to the other board. But yeah, let's get that back in there. We can just check it's conductive. It's a piece of wire through a core, you know, to make it take the noise off. It's, you know, it's an EMI thing, you know, electromagnetic interference at the end of the day. Just press that down. Yeah, I think someone used hot air around there and that's just fallen out. So clean up as I go along on this one, just for some of these things, some of these bits here. So the next thing we're going to do here is straighten up these caps, being very careful not to smash them. All the ones around the board here, I want to make sure they're not short into anything, and inspect all around. We want to look for broken resistors like we had in a previous video. Right, most things straightened up or straightened out. Let's just get the can off that modulator. Just curious to have a look inside it. Should just prise off unless there's any solder holding that on anywhere. It's probably corrosion that's holding it on actually. Sometimes there's a little metal thing there, the way it's, there you go, soldered onto the inside, so that's the lid, we can clean that. So yeah, a little on the inside of that, that's alright, but there is, however, some down there. So yeah, anyway, we'll leave that lid off for the moment. It's one less thing to look at. Let's get rid of that fuse, because that's a crazy fuse. Yeah, don't be just putting random fuses into things. If you've not got the right fuse, research it, find out what size it should be, and order the proper fuse. 3 amp there, there's no way a 3 amp fuse goes there. And that's a mains rated one. I mean, right, they probably are mains rated actually, the ones that are in there. Probably, if you look at it, it probably says 240, 250 volts. That fuse holder there is going to need a bit of a clean up as well. It looks a bit dirty. There's a cap there, look. Yeah, so any caps like that, I'm just like pulling straight up just to make sure the legs are not doing anything crazy. There's another one down there that I didn't spot, but again, I can see clearly it's not in the way, but nevertheless, I'll just grip it and just pull it straight. Yeah, so most of the caps on this are fairly straight now. Most of the bits of solder, if not all of them, have been removed. There's still one down here. There's still a bit of solder there. So I think the next thing we'll do is we'll get that 7406 and I'll get 3 40-pin dip sockets, and is it 24? I think it is for that, and we'll get those sockets on. I'll try and do that. Yeah, I'll show you one of them and I'll just whiz through the other ones. But right now I need to unblock the holes there. Now if you increase your soldering end temperature like I did before, do remember to turn it down. And there's the chip from the other board. Pin 1 is at the top here. Yeah, so I applied a super minimal amount of solder there, and actually looking from the other side it looks factory. None of the solder was leaked up there. From this side you can see, yeah, there was a really minimal amount there. And you can see that there. Can you see what I mean? If you look at the side of it, the solder has not wicked all the way up the legs. Yeah, it looks okay. It looks like no one's even touched it from this side. Yeah, so I just measured it on the other board, and it's 1K pull-up. So I've got what I think says 1K here. It's blue, but it doesn't matter. Yeah, 1K. So we'll get that on. Let's just pull these off. Yeah, it wants to be sort of like that, and like that. There we go. Just push it into position, bend the legs out a little bit, flip it over, and solder it on. Let's just trim those off. There you go. No one would ever know the 7406 spin off and that resistor. Anyway, that's two less things to deal with. I think the next thing actually, I was just thinking about that third board, the parts board, and it's going to be a parts board. There's no way I'm going to try and rebuild that board. I think I'm going to take the sockets off it and put those two sockets on here. One of them's single wipe, but it'll be fine. Certainly for a CIA, if they don't get hot, it'll be fine. So yeah, I'm going to take the two sockets off that other board. There's a turn pin one. I think the turn pin one will stick for the CPU. So yeah, you can see that resistor there. That looks fine. And obviously our chip. And you can see what I mean about the minimal solder points there, because there's literally no legs. It was trimmed so short on the other board. Yeah, and hopefully you'll agree with my thought process here. You know, I mean, I can reclaim everything off this, the few bits that are left on it. But, you know, you're missing, you know, CIAs, CPU, VIC. I mean, obviously the same things are missing on the other board, but we've got sockets, so I can use those two. I'll stick that one as the CPU. That's one of the CIA sockets. I will clean and inspect it first. We've also got another socket there that I'll use for the PLA. Again, I'll clean it up, replace any pins that need replacing. But all these caps may as well replace, because the majority of the stuff here is missing as well. You know, all the pin headers, the passives, the EMI components, you know, filters. Look, these 3-pin things here. Some of those are missing. The joystick ports are missing. Power switch, socket, filter, fuse holder. You know, transistors, diodes. You name it. There's so much missing off this board. You know, the tape transistor, I think, usually goes over here, doesn't it? That's gone. They seem to have done a relatively good job of removing things there, but you know, obviously some mangling's gone on there for some reason. Was that originally soldered straight on? It could have been. I forget what component that is, because I think the VIC is there. I think that's the CPU, isn't it? So someone's obviously removed that. But then we've got this mess here. Well, we can take that socket off. Yeah, so I'm just going to use this for parts. That connector's pretty good. That looks in mint condition. Might need to take this one off here and put it on the other one, because the other one's got a little bit of creaminess in there. Might do that. So yeah, ultimately between this video and the previous video, we would have made two C64s out of the 3 boards really. But both boards will have ended up with lots of chips I've had to provide. It's a shame that someone took all the chips off, because then these would be proper you know, repairs rather than rebuilds and then repair. So unblocks the hole with the engineer solder pump there. I'll just clean around that. So solder that in place. So I unblocked the holes here. That bit that was balked here, it was the tracer come right off the pad with the through hole, but the through hole's still there. So just carefully pushed it back into the hole, pressed it right down. Used the solder pump, unblocked it, but it's still back in there with its through hole, which is a good job, because the pad is missing on the other side for that one. So I took the fuse off the other board. This is one that's been on there from factory. It's got the red thing there and on the fuse holder, and it's marked 3AG, which means it's car, you know, automotive glass. I think the glass there. There's no F, or, you know, F would mean fast blow, T would mean timed. The benefit of it, the difference between a timed one and a fast blow. A timed one, let's say this is rated at 1.5 amp, which is what it is. Let's say you were to a surge on first power on of current, because you've got no power on the board. The caps need to charge up. You might get some inrush, and you might get 1.5 amp drawn straight away. If you had a timed fuse, it wouldn't blow. Yeah, it would take, I don't know, so many nanoseconds for that fuse to blow at 1.5 amp. So that short surge as it comes down, just below 1.5 amp to an amp, or less, half an amp, it wouldn't blow. If you put a F fast blow, as soon as you got that 1.5 amp spike, it would probably blow. So yeah, we need a 1.5 amp fuse. It is rated 250 volts. So I mean, that technically would work. It's not a good idea. It's not the right package, even though it was technically squeezed in there. But of course, it's twice the size, twice the rated size. So if there's a short on here, I mean, the power supply won't provide it, yeah. But it's good practice to get in the mindset of never uprate a fuse, because if you uprate it, let's say this was a mains powered device and you put a fuse in that's twice as much, a short circuit could occur. That fuse wouldn't blow, perhaps, yeah. Let's say it was drawing 3 amps. Well, 3 amps drawn through a board can start a fire. Yeah, you're then at the mercy of your power supply. Will your power supply provide that current? Will your power supply fuse blow? But so never double the size of a fuse. Always either underrate it or match it exactly. Right, so I've got a fuse here. I am just going to try and clean this fuse holder a little bit with a wire brush. Actually, just get it in between the two contacts. Do check you've not got any strands from the wire brush flowing around afterwards. Just because it looks a bit dirty there, that's the reason to clean that. And we'll get our new fuse in. There we go. Right, let's go and power it on. In order to do that, we need to short some of the contacts here. So I'm just going to go compare on the other board, see when the contacts are in the closed position. It's probably going to be these sensor pads here. That one's going to join to there or there, depending on which way the switch is, and that one's going to join to there or there again, depending on which way the switch is. So I can just like blob some solder over some of those contacts there. I need to just go check that before we do that. So I've just compared on the other one and confused myself as well. Switched it on, no video. I'm like, oh my god, the VIC's dead. The VIC's dead. Oh no, please don't let the R1 VIC be dead. I didn't have the fuse on. The fuse wasn't on there, was it? Right, so it's to be on, it's the points towards the outside, nearest the edge of the board here, centre to the outer one. Be very careful not to join across, because you might join the the AC coming into the 5 volts or something. But we can just literally blob some solder like that, and yeah, huge amount. And try and bridge. I might have to have a wire here. There we go. That's what I was aiming for. And then obviously measure afterwards, just to make sure you don't have any shorts where you don't want it. And check the other side in case it's leaked out and gone everywhere, because that could be the next thing here. That one's not going to join, is it? Is it? There we go. There is a technique to that, trust me. Yeah, let's let that cool down a bit, but let's just flip it over. Yeah, you can see it's not gone like everywhere around there, but anyway, let's just clean that. Definitely no shorts between the two separate sides there, so let's go and give it a try. Because we don't have a power switch, we need to obviously disconnect the power there. That's how you're going to have to switch it off. So I'd like to be ready. Just point you up a little bit, just in case you can see the fuse there, in case that blows. Now I could measure to avoid that. I've got plenty of those there. I could measure the bridge to make sure that's not shorted. I could measure the across these. I could measure across the 5 volt and ground on the main thing there. Let's just plug that in. So we'll measure from the ground outer edge there to over here. 0. 0. It's not powering on, is it? That's interesting. It could be that this here, and is this warm? Could be that this is over voltaging, because there's next to nothing on the board. There's like so few chips there. That's a possibility, certainly with the inrush as well, because I do know that will cut the power when you've got the inrush. Yeah, now we've got voltage, look, but 3 point... No, that's cutting the power. That is a pain. Let's just disconnect that, plug that in. I know what's happening here. There's not enough chips on the board for that to... Yeah, that's 12, look now. Yeah, so hopefully you understand what I mean. That power saver will cut the power if there's more than 5.4 volts. When you've got so few chips on here, The power supply's at around 5.4ish already when there's no load, and because there's no chips on here, the inrush as well, it's enough to trip it. Yeah, you've got 12 volts there, 4.9 volts there, so that problem should go away once we get the chips on. Yeah, the main 5 volts seems to be missing at the moment, I think. Yeah, we haven't got the main 5 volts, so that's interesting. Let's disconnect power. How have we not got the main 5 volts? There must be something missing somewhere, an inductor or something. It took me a minute to work out what's going on there, and I think I've worked it out. You can see someone's removed the solder, I think, or it's got a crack around one or two of the pins on the power DIN here. So I'm just going to get some solder on that. Hopefully that is the... Mind you, that doesn't look like that's used unless it's on the other side. Yeah, anyway, I'm going to reflow that. But I'm trying to work out why the 5 volts isn't getting anywhere. It could be that there, that little inductor. Maybe that's open. Let's just measure that. Yeah, that's alright. That's not open. I don't know. It's a bit of a weird one, this. Now, just moving the probe up, you can see I've got a ground strap there connected to my probe, just to free up my hands. Because it means I can then put pressure here. And now if we measure here, this is the little inductor that carries the 5 volts onwards, and if we press on that, you can see the moment none. Move the connector, 5.2, I don't know, you saw that, 5 volts again, look. So we've definitely got a bad connection there, look, none now. So I think we should get some contact cleaner into that. Yeah, wobbling it, it comes and goes, look. So yeah, we'll clean that out with contact cleaner next, I think. Maybe that's all the problem is, but I spent ages trying to work that out. So I'll unplug the power, and we'll use a bit of this dedicated contact cleaner again. And yeah, just unplug and plug this in a few times. Right, let's see what we've got now. Yeah, there you go, 5.2. None. None. So I don't know, I think it needs a new connector, doesn't it? 5.2. Let's flip it over, see if I can get any voltage on the other side, because since I've been measuring from ground there, that's when I get a voltage, but on the other side of the board I can never get a voltage anywhere here. So I'll clip this on down here, and I'll measure on the VCC pin on the 74 series. Oh, we have got 5 volts now. You see that? So we know that at the very least we need to do something with that. That is flaky as anything. I do have a spare one, I think, so we may swap that yet. But anyway, let's now focus on getting the chips in, because we know all the voltages are okay. It's Gadget from the future here. I'm adding this bit in at the end. I created a problem with that black wire. I stuck the clip there. Yeah, and it's a clip. It clips on both sides of the board. This is ground. The other side here is 5 volts. You short the 5 volt rail out if you're not careful. So yeah, that was one of the problems there, but it was the connector. The problem to start with, I didn't have anything clipped on there. The problem to start was the dirty connector. But then as you saw me clip that black thing on there for the logic probe or whatever it was, yeah, that started to cause me problems with that power rail, and I just kept thinking it was the dirty connector, and it wasn't. It was the alligator clip shorting the supply out completely. Now bear in mind, because we haven't got a switch, make sure the power is unplugged. So I get the socket in there, just so we don't damage that socket. Get the PLA in from the other board. Yeah, that's correct. I'm just looking. It's got the caps here, so that's the SID socket. We need a CPU, so I'm just borrowing the one from the previous video actually. Now this is a turn pin socket, so it may struggle to go in, I was going to say, but it went straight in. That's good. So we'll get CIA in there again from the previous board. Always inspect the pins, make sure they went in alright. You know, check them before you put them in, really. And the final thing here is this R1 VIC. I will go and find some chips for this shortly if I can. Obviously make sure you get it lined properly. I don't want to lose any pins off that, the nice gold plated ones. So that's it. We've got everything apart from one CIA missing over the left side, but the one to get it to boot should be there. We should just miss a cursor from basic, and we haven't got a SID. Oh, we got something. And black screen, isn't it? So just checking everything for temperature, no problems. So let's get the dead test, and again, this is going to be another one of these, and it's going to be one of the 257s or the RAM or a kernel. Probably not likely to be anything else. Let's plug it back in. So the interesting thing is no flashes there. So maybe it's just the kernel. That's if this now continues to boot. And it's not doing, is it? That's interesting. So there's something a bit different with this particular one versus the ones we've looked at previously. Unless the 5 volts is a bit low, but yeah, that power connector is still playing hardball, because now, as you can see, if I just unplug the power supply, it's easier than unplugging it from the board and plug it back in. We are getting something that's with the dead test cart in. So that's interesting, isn't it? So there's something different going on here. Let's just unplug that. I'll unplug the cartridge, test it without a cartridge, and see what we get. The same thing. That is really weird, isn't it? It's like maybe basic is like forcing its way into the picture here. I don't know, it doesn't look like basic, but it's kind of like monochrome, which is weird. So there's definitely something interesting going on with this one. Right, do you remember what I was saying earlier on about the shielding, and the NTSC models had it soldered on, and I've never seen a PAL one or a European one with that. Well, this should be 0.98 megahertz, the CPU, that is the CPU clock. Now I checked with Logic Pro, it was alright. I thought, let's just scope it, because I was thinking it could be a division problem here, could have been, you know, an issue. This isn't dividing down right, and then as a result we're not getting 0.98, you know, if the division of this was not correct, etc. But it's more curious than that, because, well, it's not really curious, but it confirms my thought that when I was like, is it an NTSC one, this? And actually, if I probe the CPU clock, here we go. If you look down there, 1.02. Yeah, NTSC, the US ones are 1.02. PAL are 0.98. So, yeah, this board is switched into the NTSC position. Now, there's going to be a few jumpers. I need to go check those, change that. We may, well, we probably will need a different crystal as well. But that's only going to affect the colour. So I'm not really sure the bearing it's going to have there. I think there is a fault. It could do though, because there's a time difference. The jumper could be causing a problem here. I don't think so though. I'd expected the colours just to be wrong like they are. You know, that's why it looks like this washed out, because the chroma isn't correct. Yeah, you can see one of them down there. Can you see that? Short. Yeah, 2 different types of PAL, but there's more to it than that. That's just for PAL. You know, this must have originally had, or will have had, an NTSC VIC on here. I think the CPUs are the same, it's just the VICs actually. So there's probably another jumper or something here somewhere. We may even need to change some of the components other than the crystal. Not too worried about that at the moment. If I had a display where the colours were not correct and stuff, then I could live with that. And this TV will display NTSC. Right, let me just switch this off. It's not any different. I've changed that jumper there to PAL from the left hand side to the right hand side, and changed the crystal. Got the one from the C64C that I think I reclaimed ages ago. The one that was on there was a 3-pin device, strangely enough. I can put a ground strap on that later. I can't see any of the differences. The one up there is just a different type of PAL. We're still not getting any colour, but you see this modulator is going to be modulating for NTSC. But mind you, we're not using that at the moment, but I still think the composite is provided by this. So that would explain the colour thing, but we're getting exactly the same behaviour. We can now, of course, though, scope the CPU clock speed again. Let's do that. Yeah, there we go, 0.98. It's jittering a bit, a little bit of jitter there, but 0.98. So that has worked there. Yeah, so since I changed the jumper and the crystal, give it the power. See, pretty much, that's pretty much how long it would take normally. Yeah, so yeah, my other thoughts here, the next thing I would have preferred to, would have liked to have done, is we've got both CIAs fitted, fit SID, I put a gaming, you know, a cart, connect to data setup, do shift run stop maybe. maybe more than one thing going on here. I think that's basic. I think the video side stuff is just balked. So maybe the 258. I'm going to look at the schematics and just see what I think may cause that. Right, so this is the board from the previous video. This one works. I've just been comparing because it's exactly the same revision. The only difference I see is this cap here. See this? Diagonal. Well, the jumper is set, correctly in the VIC area here. We've got the right size crystal on it. Alright, the can's not grounded, but that's just for jitter and stuff. We can do that later. My focus has been on the 373. I can show you that in a minute. And this 4066 here. It's a CMOS device there. Yeah, this is like TTL CMOS. This I think is a bilateral switch, and I think this is how the VIC accesses the SRAM, the colour RAM here, and this latches the address lines for the character ROM. I think. Now I experimented just shorting the adjacent pins next to each other. I think 13 and 14 or 3 and 4 here. A couple of the address lines on there, and you can see the video change. Yeah, so. Could it be this is not latching properly? Could it be the VIC is not able to write to this? We've got obviously a colour problem, but that's probably going to be the modulator on that other board. Anyway, so what I'm going to do, I'm just going to lift one side of this cap here, measure it, and then replicate that on the other board. The reason being is if you follow the trace, so it's just following this trace, and it comes down here, it comes up here, all the way along here, and it looks like it goes under here somewhere. Now it could go further along here, somewhere else, but I don't know, maybe it is a PAL NTSC thing still, that maybe it's expecting a clock, not maybe merging a clock, or I don't know, it might be doing something there that, because we've not got that, I mean it's probably just like a filter of some sort, but because we've not got that, maybe that's affecting timing of something here, and maybe that's the issue. But once we've ruled that out, then, I don't know, it's got to be one of these, it can't be anything else. I considered the CIA up there, and I looked at the this 139 here, and the chip selects, and I compared this board to the other board, and they're identical. It behaves identically, so there are no clues there. But it's got to be either that, or that. I think. I'm not ruling out a problem with the AEC line, but we had that in the previous video, didn't we? On these here. Yeah, and I've scoped those, pulsing, nice clean signal. Desolder it from this side and sort of pull it through. Just leave it in place, with that one leg holding it, but just pull it through. So I clip the probes on there, and let's just see what size capacitor that is. Hopefully I've got something similar, like a picofarad or something, or I don't know. Yeah, 60.2 picofarads. I think I'm just going to check that in the schematics. Yeah, 60 roughly. I don't think I'm going to have a 60. I've got 47, I think. I might stick a 47 on there maybe. 60. See, there isn't even a component designation there, so it's not even easy to check the schematics for that one. Right, so I've unblocked the holes there. I've got a 68 picofarads, so it's 8 over. Percentage wise is not too far away, is it? So yeah, we'll just spread those that way. Of course I could solder this on the bottom side, but now of course when you're mounting a package like that, you want to make sure it doesn't touch the connections underneath. I'll just try and lift it and move it a little bit. Yeah, see if that makes any difference. So what difference does that cap make? Well, to the problem, no difference. To the video, a huge difference. Look how stabilised now. I'm sorry, there's a huge light glare at the top, but before it was like flickery and a bit noisy. It just looked like, RF. Whereas now it's rock solid, crystal clear, stable. There's a flicker there, did you see that? And it's consistent. Every time you power cycle it, it comes up crystal clear, nice and sharp. So yeah, that's that problem resolved, if you like, the noisy video. Yeah, you can see it more clearly if I hold it. So yeah, that text at the top, I am sure that is basic. I am sure that is the Commodore message at the top, the version of basic, etc. There's so many bytes free, ready. That third line down says ready, believe it or not. Now, as I say, if I go to the character ROM on a short, pins 3 and 4, we go 1, 2, 3 and 4. These are address lines. Yeah, just watch. See it? Looks different. That did cause an issue there. Let's just cycle it again. So it's not like the VIC is got some weird problem where, well, it's not like there's a problem where the character ROM is not outputting the right data. Does that make sense? This is not a character ROM problem, because you change the address, mind you, it could be. It could be. It could be like most significant bit or something on the character ROM. You can't set the colours. You can't latch the address lines for the character ROM. I don't know. I honestly don't know. This is really, really weird one, this. So I've got a little bit of vinegar here. I'm just going to have a little bit of a scrub here. I'm sure I've done this already on this, but maybe not. So wrist strap on at all times while handling this. Now this is something that I would absolutely not do, but I'm doing it. Because this is so corroded here. You should have seen the green stuff that came out. Look at the cloth there, can you see? It looks greeny. There's loads of green on it. It's so corroded that. And I think that this might be why Diagnostics is doing nothing. So I've got this super fine, it's almost smooth. You can rub your fingers on it, it just feels like resistance, not really sandpaper. The noise that's making makes me realise that that is corroded actually. Because it's not abrasive enough to make that kind of noise. Certainly this side up here. Yeah, so never do this to a system unless you're going to swap the slot, because ultimately you'll wear any gold-plated contacts. Yeah, they are gold-plated, but the ones up this side here, they're worn. You can see because it's going green here. Look, corrosion has got in there. I just want to see if I can get any signs of life, and if this is balked, and this is the reason why it's not booting carts, we will swap that slot for the other one. Right, still no different, so let's just step through the motions. We'll get some deoxit, last little bit, look, on there, and clean this as well, because obviously it's been going in and out that dirty slot there. There we go, so that was a bit dirty. Let's try it again. Little ESD generators still having a nap there. Again, just a black screen, so I don't know, it's doing my head in this one. I think actually I'm tempted to remove the solder for that the CIA that's someone's removed with hot air, get a socket on there and get a second CIA on there, because if we do that I can connect a keyboard, and when it boots up and we've got that weird text, we can hit the keyboard and press return and go, oh look, there's a character. Actually the CPU's up and running, it's not crashed. So just inspecting here, I just remembered we had this at the beginning, didn't we? It's a cap there, however, so, but I can't see that being the problem, to be honest. But we'll stick it back in anyway. I'll go and do that now. Right, so we've got the other one you saw in a previous video coming to the rescue. I'm going to connect to the Kung Fu Flash from a previous video and program this up with the game. Yeah, Navy SEALs for example. And I'm going to try this. What I want to ascertain is, let's say, whether it's booting, and if I put something like, hang on, I'm going to try and find the blooming gap now. If I put Navy SEALs or something on there, and a SID, we can hear whether we get sound, yeah? And we can see what happens with the graphics in comparison to what's happening in BASIC with the character ROM. Navy SEALs. Flashing, I'll wait for that to boot. Because I updated the firmware as well to 4.1 on there. So that's working. Yep, switch that off. Wrist strap on again. Arm SID into here. Not worried about the round pins widening that. It's going to have something like that in there. Probably a nano swin SID. We'll remove the dead test. Again, it just comes out really easily, that, so maybe it is about this socket. And let's get Kung Fu Flash in. Switch that on. It's red. Now we do have a difference. This is the thing. It is behaving differently to the dead test. Dead test just stays stuck on a black screen. This doesn't. Obviously it's not starting. I've reseated things here just to make sure it's not sockets and things, and no, it's mysterious. The one thing that got in common with this car and the dead test is neither of them are booting properly, are they? Yeah. So it's not just like this is booting up and we've got a graphical thing. There's something more going on. I'm wondering if the kernel here is the problem. Like when you're disabling it via the slot over there, that isn't happening. It's weakly affecting one of the data bus lines. I guess we could scope the data bus. I think we should get that CIA on, actually, because that's a productive thing. It's not like guesswork. We know that needs to go back on. We know I will get this working. We know that, because I'm determined to get it working. I've spent 2 weeks fixing this. I will get it working. So let's get that CIA on. Let's just boot to basic and see what happens with the keyboard. Right, got another socket on there, and you can see an 8520. Yeah, it's an Amiga CIA. I'm getting a bit lazy. I've got CIAs. I just can't bother going getting them. So it's convenient. It was to hand. The only difference is the time of day stuff will be incorrect, so it would fail on to timer stuff to do with time of day. But it will work, and you can see that here if I switch it on. And that's what we were looking for. See that flash, flash, flash? It's booted. It's booted. That tells us a number of things. It tells us that BASIC's alright. It tells us the kernel's alright. It tells us the CPU's alright. It tells us probably the RAM isn't the issue. It could be, but there's enough there in terms of the stack and everything for that to just behave normally. It's just a video thing at that point, isn't it? Colour, we know what that is. That's the modulator. So anyway, let me power it off. I'm going to connect the keyboard up. Let's just see if we can type. Let's see, press return. Look, the cursor goes down. Shift, run, stop. Hang on. Now that's not working, interestingly. So I can press return, I can't do shift, run, stop. Let's just type some letters. Delete. See it got on the end of the screen there? Is that going to be the 258? Because it's mapping around, look, it's wrapping. I've seen things where you get wrapping on the display like that where it's the 258. But why is shift run stop not working? Yeah, so with no CIAs, we get the same behaviour. But with the Amiga CIA there, that will not boot. So the time of day stuff there is seemingly absolutely critical. So where am I at? I'm thinking 139 or 373. More likely the 373. Why I'm thinking that? Well, I've proven by shorting, I think I showed you, I'm not sure. I'll show you that in a minute if we get this working. You can short, pins 3 and 4, just temporarily. It's not a good editor for a long period of time. And you can see the video change, the characters change, which shows that this is addressable. And it shows that the addresses that are there are intended the way they are set. In other words, something is, maybe it's not able to set them. The defaulted kind of thing, or the incorrect value, and almost exactly the same value every single time. That would point to the 373. The other thing is, when we boot this, maybe this is booting, but it can't do anything with the video properly because this is not working. But then again, isn't that primarily for this? I think RAM access should still work, and the mapping within, mind you, depends what this is outputting, doesn't it? Mind you, the chip enable for that would be, I don't know, this is the thing, I think there might be two issues with this. The 139, coming back to that, it provides the VIC chip select, I think. Chip selects the CIAs. Now, I have seen a similar problem, and I looked on the pictorial guide to C64 faults. I'll stick a link down below. I'll show you a screenshot here. And the two chips it's indicating there are what I already suspected, which is one of the CIAs, U2, I think, and this chip. Yeah. So I think we'll start with that one. Let's just socket that up and see what difference that makes. So 373 off, no damage or anything like that. Really easy to get off there. So the legs were splayed out like that. So from the underside when I was desoldering, this pin here, I'd push from this side like that, so that it's straight. Then use the engineer solder pump there. And it came straight off, no issues. It was actually easy. Using the desolder station, it took me a minute to get that off if that. So the next thing is to get a socket. I think that's the right size, and try one of my spare 373s. Yes, that's nice and straight. I just need to solder it. So part of me's thinking, yeah, I know why this could be the problem, but it doesn't really explain everything. Part of me's thinking it could be, maybe these are both borked, because I'm still thinking about the run stop thing, shift run stop. Why was that not working? Both of those should be capable of scanning the matrix properly. And I think one of these is used for that. And I'm just wondering if this is one of these scenarios where both of these are balked. Anyway, let's finish soldering that. Pin 1 out of the top. So place your bets. Do you think this is going to make any difference? 50-50 on this. I don't think so, but let's try that. There we go. That's why I was 50-50. Well, it's easy to say that in retrospect, isn't it? But I think I would have been more surprised if that did fix it, to be honest. But we've ruled it out. It ain't that. Right, I think my next logical guess here is the 139 here. Because whilst I say activity, you know, it's not like consistent. You can't test it for long enough to see, you know, to get a long low. So what I mean is, it will set the chip select on one of these CAs or both these CAs here at various points, but just for a split second. Yeah, like you might see a flicker. That's it. And you're like, so was that low? Was that high? How high was that? I mean, I could do a capture on the scope maybe. And we could do that in retrospect if we find that is the fault. You know, I could put the old one back in, we can scope it, we can put the new one, we can scope it, and I can show you where the actual issue was perhaps that way. But, yeah, I don't know, it's like I say, I'm still thinking, but I don't see how. What I'm looking for here is how could the system not be booting a game at all? If it was just something video related, you'd think the game would still start. Do you know what I mean? If it was like the VIC couldn't interact with RAM properly, how would BASIC come up? That's the first thing. But then with a game, how come a game doesn't boot? We get stuck on that screen on Navy SEALs, don't we? And it's not scanning the keyboard properly. Shift run stop's not working, which makes me just wonder if like the 139 is glitching out. I don't know, it still feels like there could be two issues with this. Like maybe the character ROM's balked, which is giving us the graphics, and something else is wrong, which is freezing the system when you try and load things. Because the character ROM would not stop the games working, yeah? But this is, in terms of related to the video issue, the right course of thought. Same with that. Same with maybe one of these 4066s. And the 139, because if the VIC chip select was incorrect, you know, it's sometimes working, sometimes it's not, it wasn't, you know, the right level, or something like that, maybe that would explain it. You know, you get chip selects wrong, things could be on the bus at the same time and stuff, and you get bus contention, maybe. Yeah, anyway, let's just take that 139 off. I know what's going to happen, there's not going to be that, but I just want to rule it out. Right, 139 removed and socketed, again, very easy to do. They're just pushing inwards is the key, really, that helped me get the solder out without an issue. Right, there we go, 139 in, it's an F, so it's not technically right, but it should actually just work to test. I'll switch it on. Oh, there we go, finally. So yeah, I knew it was going to be 50-50. As I say, I was like 50% on the 373, but all the while I'm thinking the 139 I think is more likely. And this is the thing, that pictorial guide did not suggest the 139 at all. It was pointing to U2, and that was a clue, I guess. You know, I was looking at U2 going, well, it isn't actually the CAA, therefore it has to be the CAA chip select, you know. So there we go. Anyway, yeah, I'm very pleased. Now the key is, does it boot the dead test card? So this is how a chip select problem like that on a 139 can cause you all sorts of problems. Yeah, you see, look, dead test is still not booting, so there's another problem. We aren't there yet, there's still another fault. There is still another fault. Why is the dead test not working? Oh, it is now. Oh, it's doing something different now, hang on. Maybe it's just dirty connection on that cart socket. Let's just see if it gives us anything. Oh god. Right, let's try the Easy Flash again, which has got a game flash to it. Let's just see if that works. It should be Navy SEALs, I think. Come on, do something different. Nope, that's freezing as well, so there is still, yeah, another fault. But sometimes you've just got to, you know, just keep pushing forward. You get one fault, you fix it, and then you try and work out what the next one is. And of course that's what confuses matters when you get multiple things going on at once. So right, we're in a situation where, let's just reseat this for good measure. Try it again I guess. I know you can't see the screen, but I'll tell you what's happening. Yeah, just that same border in the middle, nothing else. See, that sort of thing where cartridges aren't working, you start thinking PLA, yeah, or connectivity on the cart slot through to the PLA. Maybe it's like not disabling the kernel properly or something like that. It just could be a socket thing, so maybe we shouldn't worry too much about that. Let's try the keyboard again, see if shift run stop now works. So you can see our screen there. Let's just do Q, W, E, R, T. Yeah, so the keyboard's working. Return, shift, run, stop. It's not working. How is shift, run, stop not working? So if I just connect the power up here, you can see I've got the 15, what's it called? Not 1541, the SDTC. Yeah, emulates 1541 with an SD card. It's not as good as the 1541 Ultimate. It's equal, I would say, in measure to the Kung Fu Flash in terms of disk emulation. Press return. LEDs illuminated on the drive, and it's loaded. Run. See, I was wondering if there was a DMA thing or something like that, a problem with that, but I think it's all about that card slot now, actually. Yeah, so if that works, I would assume that DMA stuff's working, because I think that that's probably how this would work. I got run. Really? No, there we go, that's bombs, so I don't know. Maybe that's the game that doesn't work. Anyway, I'll report back. I'll test a few games, I'll get a SID chip in it, and then I'll report back. Yeah, you can see I managed to load Spy vs Spy there. Diagnostics, the third one. And we've got sound as well. I know it's a bit quiet. Let's just hit fire. Ah, it's bomb, look. So, I don't know. I don't know what's going on now. We've now got another mysterious fault here. Right, loading games from that is totally hit and miss. I've had literally nothing actually working properly. So let's level the playing field. Let's get that 8520 out. Let's get an actual 6526 in. Now these two here came from Timo Momo. There'll be a separate video on that. Let's just try the shift run stop. Oh, that works now. Shift run stop works now. So there we go. That CIA was causing some sort of problem there. So maybe it will be better now, so yeah, there we go. White screen this time. Blocks. Is that decompressing? I see something bottom left there, makes me think maybe it's decompressing, but it could be just stuck in an endless loop. Well, actually on this one we've got a correct throw. Just turn it up. So yeah, colours are obviously weird. Press space, let's do that. Right, after taking a break, I got the colour back. I'll show you by altering the dot clock. Is that there? I think it does that. Tiny little adjustment, colour came back straight away. But as you can see, we've got colour. It looks really good as well, so that's that. So the only outstanding problem is general stability is loaded. And why don't carts work? So my thoughts are at the moment, I think something like the kernel is perhaps outputting the data bus when it's disabled, just a little bit. So it's not enough to kill it boot normally, but it is when you've got a cartridge in and it's fighting with the cartridge. That's what I'm thinking. So I've got the dead test in. I'm going to probe the data bus. So you miss the first three up here, like clock pins and things, and then it's like 1, 2, 3, 4, 5, 6, 7, 8 data bits down there. They start at D0 all the way down to D7. And I'm just going to look at them with the cartridge in, and then we can do the same thing with the cartridge out. So ignore the voltage at 86 volts. But what's this here? This is on the data bus. So we have got something going on there. Let me just count those. I'll do the run stop again. Let's just go down. So we've got 1, 2, 3. So we've got D0, that looks alright. D1, and mind you, you've got the same thing there, I can see it there. Let's go back. Same thing there as well. Look at that little peak at the bottom down there. Something is on the data bus. Now these are on the data bus. We've got a good LS139 there now. That was what got us basic up. So basic sits on the data bus. Kernel sits on the data bus. That's on the VIC side of things. So it's going to be one of these, isn't it? It's going to be one of these. Right, it took me 2 minutes to socket that. It's going to, it disables the kernel anyway, but now the kernel's not there to interfere. If this works, we know that's exactly what the problem is. How are we going to get anything other than a black screen? Right, 2 minutes later, Mr. Basic is now gone. Now I cannot see what could possibly be clashing on the data bus. So just checking the dot clock on here to make sure it is 7.88 approximately. Yeah, FB17 here. I think that side I'll show on the scope. Bobbing around a bit. I'm not sure why this scope can't hold a fixed frequency. It does that on all signals I scope generally. Bobs up and down and around a bit, but 7.8 is the predominant frequency when I'm holding steady. So that's that. What I'm going to do next, I am going to remove the CPU, and we're going to look at the data bus actually. I'm just curious, is there anything on the data bus? Have we got like one bit that's at a vault or something? I don't know. This is the thing though, I mean, I'll be honest, I wanted one like this, but now I've got it, I don't want it anymore. Right, let's put power on. So we've got video, which is interesting because we don't have a CPU, but that's how it works. So scoping the data bus with no CPU. So we skip the first three, that's the first bit. And we've got high there, we've got some stuff there, and there. How are these high? There's nothing even in the system. I don't know. What are those bilateral switches? Do they sit on the data bus? Does one of those sit on the data bus? Maybe one of those is just like cheesing me off here. It's like interfering a little bit. While there's no actual clue here to say do or do not, I'm going to remove U16 and socket that up. That's a bilateral switch 4066, because there are 4 data bits there that look like they're connected up to the main data bus as well as the VIC's data bus, I think. I think the VIC goes to the other side actually. It's a way for the VIC to interact without having a, you know, output enable control or direction and all that sort of stuff. It's quite a clever design really. So let's just get that off. Right, the kernel and basic back in. That's what happens when you've not got a 4066. Yeah, you get rainbow coloured text there, so that's worth noting. Right, so good old connectivity. Found a problem. You got ground on that first pin there. A0, 1, 2, 3, 4, etc. all the way up to A15. So it's the 5th one along 1, 2, 3, 4, 5, that one there where the trace goes. And I've got that on that 5th one. If I probe down here, no join. Do the one before it. That join? Yeah. You should go to this next one here. And it doesn't. So yeah, we've got a break, can't see it anywhere. So I just need to wire from there to over there. So there's the wire. I took it from here because it was joined all the way at the cart slot over there. So yeah, if this works, it's another Occam's razor. You know, cart slot doesn't work, it's the cart slot. Do you see what I mean? It's like I've been looking at this as if there's something crazy. Now that address line missing from there could have been affecting something else. It may be missing from something else, which is why it could be a bit flaky in terms of loading games. Maybe it's not even getting to the RAM, but then it is reporting the right amount of RAM. Anyway, let's just see what happens now. Can it power up without the cart first of all? So as usual, it's booting with the same amount of RAM. There we go. That's what it was. It's that missing connection. But like, where is that missing? There was no damage around that CPU at all. So I don't know. That could have been a very old fault. But nevertheless, it is now working with carts. Right, some more corrections and maybe some progress, I think. So, yeah, it's still flaky loading certain games. Cartridge games, you know, from the Kung Fu Flash and stuff, not everything works. Cookie, I'll show you in a minute, you get corrupt graphics, which is weird. And then I put the normal Diagnostics cartridge on there, and it fails on the second RAM test. Yeah, it doesn't matter what you change in here. Yeah, it doesn't point out a specific RAM. It's just like, you know, the RAM in general has some issue. The 139, that wasn't the issue. I fixed it inadvertently at the same time as when I swapped that. I'll talk about that in a minute so you know exactly what actually fixed it. But yeah, I always retest things. It's got the original 373 and the original 139. Yeah, so I'll let that run through, but this is repeatable. Every single time you run this, it fails on RAM test 2. But it actually says RAM test 1. So watch this now, RAM test 1 OK. Watch the text at OK. Change this to bad, even though we're on RAM test 2. Which could lead you into the realms of thinking it's the RAM. Now, I read something about this revision of board, and I think someone was having problems with it, with the modern PLA, and they added a capacitor on the RAS connection here to ground. So tried that, didn't make any difference, but then I thought, well, this one over here, what's this doing? It's not on the CAS or something, is it? Or it's not on the RAS. Turns out, it's actually on the AEC line. It goes over to here. There's a dead short. You know, one side's ground, one side goes to the AEC signal, which controls the output enable of these RAM timing. So there you go. And cookie. Yeah, look at that. So obviously it's working. It's just a graphical thing. So is that RAM? You know, the same thing. Some RAM glitch there, or is there a missing connection between the VIC and one of its address lines or something? I don't know. I just find it hard to believe that other things would display properly. So yeah, very weird. So the board from the previous video, you can see the RAM passes alright. That's using all the same components. Now I did just kill one of the PLAs. I'll talk about that in a sec. So you can see that's the one we fixed in the previous video. So anyway, we'll disconnect the power there and we'll swap the parts back to here. Yeah, PLA, I tested in the ZIF board. The ZIF board has these two sockets the other way around. The voltage display on that was showing 7 volts on the 12 volt rail, so it's straight off. I thought there's something weird going on. And he inspected and went, oh, I've got the PLA in the SID socket. And took it out, put another one in, it booted in the correct socket, and it booted okay. I put the other one back in, dead. Left hand lattice chip there, GAL, is getting really hot. Now it just so happens I've got a couple of spare chips there, at slower speed, which actually might actually help with what I'm trying to diagnose here. And there we go, PLA removed, so actually no pad damage on that side at all. I did make a bit of a mess on the underside here because I'm just in a rush to get it off. I don't care about this board, it's not, you know, I don't want to repair it. There's far too many things missing off it. Yeah, you could argue that it was repairable, but it would have needed a lot of components. It's far easier to just take the components off this board, put them onto another board. You can see these bits here, it's just where I had the extractor tool, where I used the hot air to remove these. It just wore away a little bit. It didn't really delaminate, it did around the RAM a bit. Yeah, you can't really see it, but it just looks, yeah, it looks a mess, so I wouldn't even want to stick this on the wall really, it'll just go in the bin. So I just now need to straighten one or two of those legs. They're crooked from factory, you know, the way they install it, they're just like little, a few of them just bent one way or the other a little bit. But yeah, no through hole or anything like that. And they're all intact, so that's quite good. I could test that on that board that's socketed actually. You know, this is the one that's got the RAM built in. Be interesting to see, does it work? Is it pin compatible except for the SRAM? Could you actually add the SRAM external? I don't know, so I may revisit that in another video. Right, I think I've worked this out. The CPU has got a port here, hasn't it? Like 5 bits or something, P1 to, or P0 to P5, P1 to P5, I forget. 2 of the bits there are used for the high RAM and low RAM to page RAM banks, yeah, via the PLA. So if I go down here, let me just think about this, it's 7, it starts from 7 down the side here, 1, 2, 3, 4, 5, 6, 7. So I think this is one of the RAM ones. They've got 2 RAM ones and then the character ROM one, I think, or character RAM, I don't know. So let's just, hang on, it starts there, that's 5, 4, 3, 2, 1, there we go, so that one's joined. The next one down, this is the one that's missing on our board, it goes there, the next one up, yeah. So we can confirm that if we go down from pin 7 here. So that's the first one. So that one's there, and then it was the one above it was, sorry, the one above it was the next one. It's not joined. It's not joined. That's what it is. So that would explain the RAM issue, and probably the graphical issue. Because if you can't page RAM banks properly, you're not sticking sprites in the right place, etc. And it would also explain why it's super flaky, loading lots of games. So yeah, just with a bit of thought about the schematics and looking at how this is laid out and the architecture stuff there, that was really the only other thing to rule out, other than to consider starting to swap these followed by those. But there was no definitive thing there, was there? It's not like a bit was faulty, yeah. And obviously it was booting basic, so that gives you a bit of information that something like banking might be the issue. Like with the PLA, that's where things are going wrong, I think. So yeah, I'm going to fix that trace and we'll retest it. So I think this should probably load cookie as default. Let's just see. Yeah, there we go. Hey, there we go, fixed. Haha, that was the issue. So yeah, it did take me a bit of pondering and staring at the schematics to finally work that one out. But yeah, there we go. Oh, I'm very pleased. That looks fantastic. Let's now try the Diagnostics cartridge. Might order a power switch and do that within this video as well, I'm not sure. It's looking more promising. It's taken ages now to do that RAM test too. There we go. Passed. It's going to fail when it gets to CIAs and things because I haven't got the loop backs, as I mentioned in a number of videos. You know, it outputs on unport and input somewhere else onto a joystick port or something like that, so that you can test the keyboard, the serial joysticks, etc. But yeah, that's fine. That's fantastic. Absolutely brilliant. So coming back to that 139, why wasn't that the fix, and why did putting the old chip back in, why was it working afterwards at that point? Bad solder point, you're thinking. It wasn't. At the same time I did that, I noticed there were 1 or 2 vias around the CPU and the CIA over here that were totally unblocked. There was no solder and they looked just a bit dirty. And I think what had happened is delamination, because hot air's been used to remove some of these chips, and you just get a little bit of delamination where the layers just warp a little bit, and you've got through hole in the middle. And if you lose the connection between the solder that goes to the through hole on the top or the bottom, it may not pass the connection from the top to the bottom side. And I reflowed like literally 2 or 3 points there that were like that at the same time as doing that. So I am sure that's what it was. I am sure that was the issue. Because I've flexed this board a bit, put pressure on it, can't get the problem back again. But I'm sure that is the coincidental thing I did at the same time as removing the 139. Yeah, so there's nothing wrong with those 3 chips, and there's nothing wrong with those. So yeah, in that respect, it shows how, for me, how sometimes these can be quite difficult to work on. You can end up socketing 1 or 2 things to try and rule things out and seemingly getting nowhere. The case with this seems to be just 2 broken traces, doesn't it? 1 to the cartridge slot and 1 to the PLA. Now the interesting thing with that is I examined thoroughly, really thoroughly around that. There was no damage at all. The only thing I can think is the through hole must come out on one of the connections, which means that something's not passing. Yeah, it doesn't pass from one side to the other. That is the most likely possibility. So we'll test the SD to IEC again, because this is where I first sort of became aware of this weird behaviour, things not being, things not working properly, and then, prompted me to test the RAM. We got the RAM issue, and then I had the problem with cookie. So yeah, back to here. Colour change, you see that there? That's just because this has got an R2 kernel. Yeah, we didn't get that far. This particular one didn't come up with that. Yeah, we do have the sound of spring wire. Oh yes, sweet, fantastic. Got a go at that now. This is a hack, isn't it? Yeah, it says Phosphox. I don't remember this. This map. Oh, maybe I don't know. It just looks a bit different. Hang on, it's not moving again. Oh, there we go, cuts it off. Perfect now, rock solid. So I guess the only question with this one is, what was the actual fault? Well, I'm not sure there was one. I actually think the 2 damaged traces were probably as a result of things being ripped off the board. Yeah? There must have been a trace here and a trace here that I just couldn't see that were damaged. It could be, as I said, the through hole came out, yeah, but the pad's still there. That is a possibility. The one where I pushed it back in, that was joined up all right. That was never the issue. But in terms of trying to diagnose, the things that are socketed here didn't need to be done. Those didn't need to be socketed either. It's got a different kernel there now, actually. It's got a cross there, but that actually works. I think that was to indicate it did work, so I might just clean that off. And of course it was an NTSC board as default. It would have had a 6567 here. Did that confuse somebody? Did they take that out and put 6569 in and go, why am I getting weird things? And you're going to get timing issues because the divisions are done differently depending on how the jumpers are set and the crystal here. Yeah, it's all about dividing the master clock here down to get the exact right dot clock and stuff, and the CPU clock. So of course that was all wrong originally when I scoped this. That was the clue. It was at 1.02, and I was like, it's an NTSC board. So we just changed that, and just to reiterate what we did, we moved that jumper from the left hand side there to the right, and we changed the crystal here from 14 point whatever, I'll stick it up there, to 17 point whatever, again I'll stick it up there, and obviously joined that up to ground. And then to get the colour back, obviously just tweaked this one while the other while it was on, and select the colour. And of course the downside is obviously I killed that PLA, but actually I almost just did the opposite thing on the other board. I stuck the PLA into the wrong socket on my ZIF board and nearly killed it again. So luckily it didn't die, but the trace is still intact. And on this one, I think this is where the trace was needed to be fixed, wasn't it? If I just pull this out, yeah, you can see that wire there. I had to fix that because that trace burned up. So I'm wondering if the chips that were on here were okay, but I'm sure one of them was getting pretty hot, so possibly not. But anyway, I will get another one of these PCBs. I might just get a few of those actually and build some of my own, and I can retest those chips. Now, this is using a back SID, so it sounded a bit weird there, and yeah, there may just be a few incompatibilities. I'm not sure if that was normal actually, it may have been normal, because it sounds normal now. So I'll do F1 for one player game. I'm impressed with the video quality on this revision of board, actually, it's pretty good. Now there is an issue, look. Why did that restart? No, there isn't a problem. That's a super annoying thing that I have seen before in different ways. Shift lock was held down. I want to show you this. I've pressed shift lock down, right, shift lock's down. As soon as I press down, it will go back to the menu watch. And that noise at the beginning, I think, is an incompatibility with the back SID. So if I switch shift lock off and then start it, it won't do that. So yeah, I don't know, that's a weird one, isn't it? Why would pressing shift lock and down take you back to the beginning? That is a really weird one. But yeah, it's working. I thought it was a weird CIA fault then. So the end result, all working, nice and clean, a bit ready there again. It has been a few weeks since I did that, so yeah, that rust has started again a little bit, hasn't it? You really need to, spray over these things, I think, perhaps, if you want to guarantee the rust's not going to come back. But again, just used a little bit of oil on there, like machine oil on the surface. Yeah, so marked up. It's got the cap fitted down here. I think on the NTSC boards they just weren't fitted. It wasn't that someone had removed it. The solder points were factory. It had never been fitted. So yeah, 100 microfarad cap there. So I'm not sure why they did that. I have ordered a switch for this, but the way I'm going to do that is as part of another repair, I think. And ultimately I'll put the new switch into my main working C64, take the switch out of that and put that on here. Just so that I've got an absolutely brand spanking new one on mine. But again, this will probably end up as one of my spare boards, I think. I don't really want to sell this on. There's very little wrong with it. The solder points, it's incredible on the underside. You barely know it being worked on except for these two wires. And that was the only thing I could really find wrong with this. It may have been a case it had a bad PLA originally. I killed the PLA, fixed the PLA by using the chips that Brad gave me. That'll be covered in another video as well. And I killed the PLA, as I say, because the other revision, the ZIF64, these are flipped. So of course I took the PLA out of here, went to the ZIF64, stuck it in the SID socket, and 12 volts is like up here, where something else is supposed to be, probably 5 or I don't know, some other signal. So tested for a number of hours, everything works perfectly on it, it's good as new. I do hope you found the video interesting. Please like, share, subscribe. If you'd like to support the channel, see the coffee, Patreon and merch links down below. I'll catch you in the next video.